For now, the conclusion is that the design of a solution like this, in which we have two CS stages, one is like a class AB output stage, and the other is a single CS input stage, seems feasible from point of noise, drive capability, and bandwidth. For the noise, maybe we would like to do an extra test with adding additional noise, and that can be done just by creating an extra noise source in parallel with the output of U1, which represents the noise of the current mirror. If this is not good enough for you, you could go to LT-Spice, but then you need to bias this whole thing. So we would like to do the things as simple as possible. So if we can represent just the noise of this current mirror with a simple current source in parallel with the output of U1, and you could even make a test circuit for the current mirror itself using the noise model of SlideCap to see what the value should be of this noise sources, then you can really see if this noise has to be reduced further. But we still have a lot of option in increasing the current of the first stage to reduce the noise floor, because the crossover frequency for 1/f was still quite low. It was 31 kilohertz and it can be 100 kilohertz. There's still a lot of headroom for the noise design, I would say. So it appears to be a feasible solution, but it basically, you wouldn't call this a two-stage solution, because the current mirror really adds a dominant pole to the whole thing, and it can be considered as a third stage. So the question that we have for you in your homework is to do it in another way. To do it in another way, use a differential pair for the input and see what you can get in this way. SlideCap has a symbol also for a differential pair, in which there is only one control source that you can use as loop gain reference. Of course, it has two feedback capacitors in it, but I will show you in LT-Spice. So if I go to LT-Spice, I do file, let's do a new one, new schematic, and then I could place a differential pair. Then you go to the subcircuit, which is SlideCap SL. X is a subcircuit, M is MOSFET, D is differential. So that is what you need, this one. The parameters you give are the parameters of the single transistor. So if this is the single transistor, the width is of the single transistor, the length and the drain current is of the single transistor. And this will be a simple voltage controlled current source with, of course, all the capacitors around it and the output resistance of the stage, but as the completely the balanced version as it has been discussed and described also in the book, and as we discussed it during the lectures. So from this one, you can select then GM as reference variable for the loop gain. And if you want to see the loop gain without the effects of the gate drain capacitances, you have to set them both to 0, and their names can be found in the output listing if you do element data to HTML or params to HTML.